Today we're looking into the AWS Well-Architected Framework. If you feel like, Andreas, oh my God, this is going to be that huge architecture with a lot of arrows here and there and blocks that I don't understand, don't worry. I thought that as well, and it's actually not that. It's basically a way of showing us how to build really good things. And that is very valuable if you're a software developer, if you're an engineer building something, an architect, or a data engineer who does something. So let's check it out. Okay, I download this as a PDF so you can do it. I'm going to put the link into the description of the video. I want to first focus on the important things here, what they did. And one of the things here is how they split this. They split this into operational excellence, security. They also split this into here reliability, performance, and efficiency. The first things that we think about when we think about well-architectured, reliability, performance, of course, cost optimization. Yes, that is always important. And then sustainability. I don't know about you. When I hear sustainability, I immediately think about, oh my God, it's going to be about some CO2 stuff again, and it's going to be boring. Partly. But the sustainability thing, I don't put that much effort in it, or I don't like that much. But the other ones I really like. So let's focus on these. So what are these all about? I'm going to try to go quick here because this is a 1,000-page thing, so I don't want to go through everything. A few things that I really find interesting, the general, let's say, design principles. Whenever you do something, stop guessing your capacity needs. I think that is something very important. People make a lot of wrong decisions regarding the capacity because they are just guessing the capacity. You should always try to measure stuff, try to anticipate what is going on. So that is very important. Testing systems at production scale. That also I've done many times, and I think that is something that rightly so is here in the general design principles, because you need to figure out, okay, is that solution right for me or for that use case at scale? You can very quickly do a demo, look at some benchmarks, but that will not give you really what's going on or if it's the right solution. You need to test it at production scale, so you need to pump some data through it. Also, automate with architectural experimentation in mind. I always say you need to keep an open mind regarding the architecture. You never know if you need to change something later, so you don't want to navigate yourself into a corner. But automation is one of the important things here, right? So you can stand up architecture, bring down architecture. You can change architecture based on an automated approach and not have to do manual steps all the time. So that is very important. And also, what did they have here? Consider evolutionary architectures. I already said that a bit in the previous part, right? Your architecture is never finished. There's always something going to happen. This is not like you build it and it's done, especially nowadays with AI coming in hard. So that is very important. And also drive architecture using data. I think that is an important topic here, so that you make actually here fact-based decisions on how to improve the workload, because you measure what's going on. Yeah, improve through game days if you have the time that you play around and test how new architecture performs. But I would say this is a plus. So let's move into the main architecture topics. So operational excellence. Let's quickly jump here to the design principles, because I think that is important. Here, organize teams around business outcomes. That is something that I have seen in many companies being the difficult thing, because they structure it like that's the database team, that's the UI team, that's the data science team. But each team individually cannot actually influence an outcome directly. They are always the part of the machine instead of working towards the goals directly and have really influence on the goals, which is bad for the people that are working there and also bad for actually making progress. So that implement observability for actionable insights, that's one of the big things I have struggled with before, where I actually had no idea really what was going on in the pipelines, and there were always some stuff coming up that were problematic and I need to look through the logs and so on. I never really knew what's going on until I actually tried to create or implement observability to actually generate the logs at the times where they were important from the systems that were important, and also that the logs or the information, the right information was in there. So super important. And also we have here safely automate where possible, right? You don't want to build stuff manually. That's the thing. Wherever there is a part that you can automate, and they say safely here, automate it. Manual intervention at any step is always difficult and it's always dangerous, because it's not only you who works there, it's also other people who work in the company on the project, and everybody has their individual knowledge, which can get lost if somebody else is doing it and then they do it wrong and then they fuck it up. It's always the same thing. So automate wherever you can, and also make frequent small reversible changes. That is one of the big things. This will speed up the delivery time. This will speed up also the development and speed up or let's say, help you not make these big errors where you have to reverse a lot of code and reverse a lot of development that you have done because everything was wrong, or make huge breaking changes. So make small, frequent, reversible changes. This is what people do. They ship all the time. It's not like every Monday we do an update. It's like, okay, we are making these small updates, small things every day, which is huge. Refine operations procedures frequently. Yeah. You evolve your workloads, evolve your operations appropriately. Operations produces logs. Hold regular reviews, validate. Yeah, I think that is pretty straightforward. Good point, but not like these big ones before. Of course, anticipate failure. You don't want to build something that had only the okay path in mind. You need to anticipate what's going wrong, but a good risk assessment actually helps you there. Learn from all operational events and metrics. That goes back a bit towards observability, that you actually have a good observability and you figure it out. Through that, drive improvement through lessons learned from all operational events and failures. Yeah. Okay, and then comes other stuff, best practices, organization-wise. I'm not that interested in that. Let's go to the next one. Security. Let's just look at the design principles, right? Implement a strong identity foundation. That is important. Yeah, you need to implement the principle of least privilege. You don't want to give people too much privilege, and also you don't want to have duties basically mingled together in a large identity, or into large rules. No, into the right policies. I mean, think about in AWS where you have your identity and access management and you create roles that have multiple roles in them, and like that is difficult. Traceability, right? So whenever something happens with security, you need to monitor, you need to alert, you need to have audit actions. That stuff is important. Apply security at all layers, of course. I mean, you don't want to build something that only has security in the layer that is basically facing the customer. You want to have that in all layers. Defense in depth approach, multiple security controls, apply to all layers. Yeah, load balancing, VPC, edge networks, every instance, right? Every EC2 instance that you have, you want to have security built in. Automate security best practices. Again, that comes back to the automation that we saw in the operational stuff, right? Automate software-based security mechanisms, improve ability to securely scale more rapidly, cost-efficient. Create secure architectures, including the implementation. Protect data. Here, let me scroll this up a bit. Protect data in transit and at rest. Sometimes people only protect the data in transit, so that, let's say you make an API call, that API call is secure. No, it also needs to be at rest secure, where you have your data stored in the data lake. You want to have that protected. Keep people away from data. That is sometimes difficult. but very often needed because what do they write here? Use mechanisms and tools to reduce, eliminate the need for direct access or manual processing. Yeah, this reduces the risk of mishandling or modification and human error, right? That's the important part. You don't want to have it mishandled and somebody does with the data something that you don't want, access secure data or privacy data, but also modification and human error. That somebody goes into the data lake, fucks up the data, and then you're screwed, right? So that you don't want. That's what they mean here. And prepare for security events. Of course, you need to prepare for events. You need to prepare for that something actually happens, right? You need to have here incident management, investigation policies, run incident response simulations. Yeah, blah, blah, blah. Okay, so that security. Let's go and look at reliability here. I'm trying to go quick here, but it's a lot. Design principles, automatically recover from failure. Important because you're monitoring the stuff, you know when something is going wrong, and you need to try to make the processes so that if something goes wrong, the whole system doesn't break, but it automatically recovers. Think of it like, I'm thinking of something that is Dockerized. You have a container running. If that container fails, you don't want to have it sit in a stale situation where it's basically done. You need to restart it so the infrastructure comes back up and your processing comes back up. What did they say? These KPIs should measure business value, provides for automatic notification here, tracking of failures, automated recovery processes. Repair the failure. Yeah. Test recovery procedures. Yeah. Automatic recovery from failure doesn't work if the recovery procedures doesn't work, right? So that's important. Here, scale horizontally to increase aggregate workload availability. That's always one of the big things. I think horizontal scaling is one of the big game changers for every large architecture because we used to scale only vertically, making bigger systems. And these systems at some point come to a place where scaling becomes very, very difficult because you can only throw so much RAM, so much CPU power, so much speed of the drives in it. At some point, scaling doesn't work anymore, and horizontal scaling is the big change here that really made everything possible that we have right now. So that is a very important thing. Replace larger resources with multiple small resources. Reduce impact of single failure here. Single failure impact, very important that you reduce that. Distribute requests across multiple smaller resources to verify that they don't share a common point of failure. Common point of failure is always the thing if you scale vertically and you only have one big thing. Now, of course, this is not super easy because scaling horizontally often leads to some overhead, leads to some clever planning and basically distributing, for instance, queries. But that's more of that's a different problem that we have. Then we come back here to the last 2 points. Stop guessing capacity. They already had that, and we had that in the top, the big points that you say, okay, I monitor demand and workload utilization, and that I automate the addition or removal of resources, right? That the system scales up and down as needed and automatically based on what you monitor for the demand. Manage change through automation. I talked about this already. You need to try to automate stuff. Never try to do stuff manually. I've done that many times. And my first courses that I built were also courses where I did stuff manually. I went into AWS and I clicked around. I know it's easy. I know it's interesting to see. But the best way always is to create automation, use Terraform. Have processes that automatically evaluate when you try to send an update somewhere, when you try to improve the code, right? That you have these automated structures in Git for instance, and have testing in Git that automatically tests all the features if the features still work. I think that is very, very important. Okay, that much for that. What else do we have? Let me go up. So now we have performance and cost. Performance principles: democratize advanced technologies, make advanced technologies implementation smoother. I mean, asking your IT team to learn about hosting, you need to make this whole process easy to deploy something. I think AWS already did that, but that's important. Go global in minutes. Yes, deploying your workload in multiple regions if you need. Use serverless architectures. I think that is one of the big game changers. Have stuff serverless, so you don't have to set up infrastructure at all. You just use the serverless features. Serverless storage. Services can act static websites. Event services. Yeah, removes the operational burden of managing physical service. I think that is one of the big points here. Experiment more often. Consider mechanical sympathy. What is that? Understand how cloud service is consumed and always use technology approach. Okay, then let's jump to cost optimization design principles here. Implement cloud financial management. Yes, you need to have the money in line, right? You need to have actually measurement to figure out what costs, how much, what's the development of it. Yeah, and then you need to do some cost optimization very often. Adopt a consumption model, pay only for the computing resources that you require, and increase or decrease usage depending on business requirements. I mean, that is kind of, if you use serverless, this is kind of not a big problem, but if you're still on, or if you're using some resources that are provisioned, yeah, that's one of the big things. Measure overall efficiency. Yes. Stop spending money on differentiated heavy lifting. Yeah, the heavy lifting you want to do through AWS. AWS does the heavy lifting data center operations like racking, stacking, powering servers. Already done. Removes operational burden of managing the systems, which is always a problem because you have to have people who actually do this, right? That permits you to focus on customers and business projects rather than on IT infrastructure. I think that is one of the big learnings here that you have to see. Analyze and attribute expenditure. Okay, that you actually can see who is costing you that much. Is it this department? Is it this department? Is it this project? Is it that project? That's important. Okay, the last look at sustainability. So sustainability, that's the most boring one, I think. So we're going to go through that quickly. Understand your impact, right? Understand the impact of your cloud workload and the model for the future. Include all source impact, blah, blah, blah. Compare productive output, total impact of your cloud workload. Establish sustainability goals. Establish long-term sustainability goals such as reducing the compute and storage resources required per transaction, which leads back to saving money, right? Model the return on investment. Of course, here it is. Sustainability improvements, give owners the resources, blah, blah, blah. Yeah. Then maximize utilization. That's something you always want to have. It's interesting that they have this in sustainability. Right-size workloads, implement efficiency design to verify high utilization. 2 hosts running 30% utilization are less efficient than 1 host running 60%. And that, again, comes down also to the efficiency completely for the operations and the efficiency for the costs, right? So anticipate and adopt new, more efficient hardware and software offerings. It's not very interesting for us. Use managed services. Need to support cloud workflows. Reduce the downstream impact of your cloud workloads. That is one of the things I always find a bit bloated. Like amount of energy or resources required to use your services. Who cares? reduce the need for customers to upgrade their devices. That is something that you might want to check. Right? If you're creating apps, you don't want to create apps that nobody can run because their phones are not strong enough. A bit like that, I think here. So much about that. Again, this is a huge document, and every part here. Let's quickly go back to. It's a bit hard to navigate, especially if you're zoomed in. Like performance and efficiency, they also have here definitions, best practices, resources. So performance, efficiency, best practices they have for your architecture selection, compute and hardware stuff, data management. So they give you a lot of information here as well on these networking, content delivery, process and culture. Check this out. I think it's very interesting. They also link to a ton of other resources always. But generally, I think this is a very interesting document. Is it too big? Yes. But I think focusing on a few things is very important for you to get that knowledge and have heard these topics, right? And they have best practices in there. They have how is it called? They have design principles, definitions, best practices, and some other resources. And I think that is for every one of these topics. Let me quickly make sure I don't talk. So for reliability, yeah, they have that section always. That is very important for you. Take a look at that. You don't need to read everything, but just like I did, go through it, think about it first, try to see if you have learned or have had something of this happen already and create problems for you. And I think then this is going to be very interesting. So how do you like this? Are you taking something away from this? Let me know in the comments, and see you next time.